Hey guys, here's a review for Chapter 10. We're going to start with some raw data and just work it through all the possible types of questions that that you could be asked about this material. Okay, so first of all, this is the same data that we used in the textbook about 9th and 10th graders versus the favorite meal at lunchtime, given some choices. Okay. So we have raw data here. It's really hard to draw any conclusions about that data because it's just organized. It's just in the order it was collected. But it's not numerical data, so we cannot put it and use it for scatter plots or lines of best fit or residuals or any of that other stuff that we did in Chapter 9. So we do these things called two-way tables. And two-way tables is kind of a general term, and as they're specific ones, and they have kind of wordy titles to them. Okay, so the first thing you can do with raw data is make a frequency distribution, and what you're basically doing here is going through and doing tallies in an organized way into this chart. So the two categories are grade level, 9th grade and 10th grade, and then favorite meal is the other category. So my first row of data says grade 9 salad bar. So grade 9 salad bar, I'd put a tally mark right there in that box. Okay, and then burgers for 10th grader, okay, I'd put a tally mark there. I would also recommend that you maybe not cross off as you go, because if you've messed up and you want to be able to read it later, okay, maybe a check mark. 10th grade pizza, 10th grade chicken nuggets, and so on until you've made all the tally marks. Okay, so all the tally marks are now done, and you can put these numbers next to them. Count out what they are. 1, 7, 3, 3, 5, and 4. And now you kind of start to see some interesting things, like chicken nuggets, not very popular with 9th grade, but 10th grade loves them. Everything else is kind of even. Salad bar looks pretty popular added together, and that brings us down to our next kind of chart. You'll notice that the next kind of chart, frequency marginal distribution, has, what makes it different is it has the rows for totals. It has a row across and a column down. So in these boxes, it's all the same information: 4, 3, 1, 7, 3, 3, 5, and 4. Okay, the total rows is exactly what it sounds like you do. So the number that would go here would be 7 because 4 plus 3. The number that would go here, 1 plus 7 is 8, 3 plus 3 is 6, 5 plus 4 is 9, and that's adding down. Now adding across, this is 13, and let's see, 10, that's 17, and this box here is very special. 13 plus 17 is 30, and 7 plus 8 is 15, 21, 9, that's also 30. 30 represents the total participants. I'm not going to spell all that out. It's total participants, total number of people or objects that were counted in the information or counted in the data. Okay, then here's a mouthful for you. Relative frequency marginal distribution. And basically what you're doing here is, if I can get it to scroll down, taking what relative usually means is a percentage. So I use the example in school, a really extreme example for the word relative. If a homeless person were to get a scratch-off lottery ticket and they won $10 on that scratch-off lottery ticket, that could mean like food for them for the day. That would be pretty important to them. But if Bill Gates were to win $10 on a scratch-off ticket, wouldn't be very meaningful to him. So because the difference is that the number 10 isn't that meaningful until you compare it to the total amount of money that each person has. $10 to a homeless person is a pretty high percentage of the money that they have. $10 out of all of Bill Gates' money, that's a very, 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 very small percent. So relative is usually asking you to convert things to percents, and that's exactly what we're doing. So first, we're going to set up some fractions in each box, okay? You're going to use as the top number is the number that was in the box, so 4, and then it's over the grand total. So 4 over 30, and then you would divide that out. Divided by 30, and we're going to round that. Now the book was not consistent with how they represented percents. Guys, in my opinion, if it's a percent, it's a percent. I moved that decimal over 2 times, but I know the book is not consistent. Sometimes it leaves it as a decimal, and sometimes it says percent. Even though it says percent, it'll leave it as a decimal in the examples, and sometimes it actually makes the percent. Okay? 3 out of 30, that's 10%. Again, you're just going in your calculator and dividing 3 divided by 30. That's one I know in my head. That's 0.1. Move the decimal over 2 times, 10%. Okay. 7 over 30. Would be 23.3%. You'll also notice that 13.3% and 10% add up to 23.3%. And most of the time, that will work out perfect. However, if you end up rounding it all, sometimes you'll be off by a tenth or so. So again, we're going to just continue making the fractions and converting everything into percents. So I'm going to pause this while I'm doing that, because you don't need to watch me do that a whole bunch of times. So here's the chart totally done, and you can see like 3.3 and 23.3 don't make a 0.7 here, but it's because these are both rounded down. But 8 out of 30 would round up, because that would be 26.6 repeating. Okay. Then there is all the graphing we did in this chapter. Okay, so when we have our two-way table and we make a side-by-side graph, you have to listen to directions or read directions very carefully to know what are they putting on asking you to put on the x-axis. So if they say to put meals on the x-axis, that's what you're going to do: burgers, chicken nuggets, pizza, and salad bar. And that means that you're going to have 1 bar for 9th graders that reaches as high as 4, and 1 bar for 10th graders that reaches as high as 3. Now notice the 2 bars touch. This is not a histogram, okay? Non-numerical data, so it's not a histogram. These 2 bars touch, but there's a key, 9th grade, 10th grade. That's important. You must make a key for these graphs. Then there's a space. And then the next 2 bars for chicken nuggets is 1 for 9th grade, 7 for 10th grade. Pizza are both 3, etc. Or we could organize the data by grade level. It just all depends on what you want to know, and what the directions say. If the directions say put the grades on the x-axis, then that's what you do. Again, we've got a key, so solid red is burgers, pink is chicken nuggets, stripe is pizza, and plaid is salad bar. So we have 4 ninth graders saying burger, 1 saying chicken nuggets, 3 saying pizza, and 5 saying salad bar. And then we have all the 10th grade data side by side over here. Okay. We could also make stacked bar graphs. Now the book had you make stacked bar graphs by percent, and you don't have to. I mean, that's not a rule that all stacked bar graphs always have to be percents. So I made one of each kind. I made one stacked bar graph with just the actual numbers, like the 4, the 3, the 1, the 7, the 3, the 3, the 5, the 4, etc. And it's basically the same idea as above, except that instead of having these two bars side by side, they're stacked one on top of each other. So you just have to be careful of, if I know that burgers, 9th grade has 4, okay, so that's easy to draw that bar up to 4. And then the next one is 3. So I need a bar that's 3 high, and so 4 plus 3 is 7. So adding these totals up, 4 plus 3 is 7, to get the height of the bar is, how you want to do this. And in class I demonstrated like keeping a running total like in the corner of your chart. Okay, this one over here I did by percentages, and also the x-axis has grade levels. So the red bar represents burgers for 9th grade, so that's 13.3%. So you can see here's 10%, so I approximated this up to about 13.3%. And then I'm adding on 3% more. And so if I add on 13.3 plus 3.3, that's about 16.6%. So that's how I know how high to draw up my next level of bar. And then my green bar is going to be 10% more than that, so that's 26.6%, adding that on. And then 16.7% more. By the time you got to your last level is going to be the same height as your total. So you can cheat a little bit. Sometimes when you add across, especially if you have rounded it all, if you add your percents across, they might be 0.1% off, and that's okay, especially for graphing purposes when we're just approximating graphs anyway. Okay, so those are our stacked graphs. All right, then lastly, the last part of this chapter is interpreting information that you see in the two-way tables. Okay, so it says what percent of students chose burgers. So the word of is kind of a helping word to determine, what group are we talking about, because now this is conditional, and we're asking for percentages not like the percentages from the chart on the previous page. Okay, these percentages down here from this chart, not always going to be helpful, okay, because we might be talking about a specific group. We might just be talking about the people ordering burgers, or we might just be able to talk about one grade level. So there might be some conditions to our percentages. So this says what percent of students chose burgers. Of students and chose burgers are the two things, and we're making a fraction out of this. So of students is pretty general. It's not talking about a specific grade level. It's just saying of students, so that's 30. And chose burgers, it's not being specific in grade level, so that's 7. So 7 out of 30, if I divide that out on our calculator, 7 divided by 30 is 23.3%. So that one is out of 30. All right, the next one says, what is the probability that the next 10th grader will choose chicken nuggets? Okay, probability, we're asking the same thing as making a percent. Okay, so the next 10th grader, we're only talking about the 10th graders. So we're not using the 30 as our denominator now, because we're only talking about 10th graders. So if we're only talking about 10th graders, there's only 17 of them. That will be our denominator. And we want to know if they're going to choose chicken nuggets. So 7 out of 17 have already chosen chicken nuggets. The point is to, if that seems to be how things are going, then the chances are 41.2% that the next 10th grader that comes through the line is going to choose chicken nuggets. Okay. What percent of 9th graders did not choose pizza? Okay, so now let's see if I can carefully erase this line. Now I am specifically talking about 9th graders only. So there's only 13 of them and did not choose pizza. Okay, so burger people didn't choose pizza, that's 4. Nugget people, 5. Salad bar people, that's 10. So 10 out of 13 did not choose pizza. And that is 76.9%. Okay, so favorite meals of students, unless it is an extremely, extremely small school, all right, 30 is probably only the total number of students surveyed. It is probably not all the students that attend the school. Now, remember, when you're conducting a survey, you're probably not asking every single person. It's just like when you open a new flavor of potato chips, you don't need to eat the whole bag to know whether or not you like them. You sample a few of them. So sampling in math, or specifically in statistics, is where you're studying the whole population of, say, 9th and 10th graders, but you're not going to ask all of them. You're just going to get kind of an idea by asking a small number that's going to represent everybody. Okay? So the last kind of question you could be asked is, if there's 276 students at this school, how many burgers should the cafeteria prepare for the 10th grade lunch? Okay, so 10th grade lunch, burgers is 3 out of 30. And we're taking out of the total of 30 because we're setting up a proportion. 276 total students. So if it didn't say 276 10th graders, it said 276 students. So I have to compare apples to apples. We have to have a denominator of 30, because that's the total number of students in our survey, and a denominator of 276 represents everybody. So if 3 out of 30 students in 10th grade wanted burgers, then I don't know how many, so we'll say X out of 276 are going to want burgers. So this is a proportion. When I solve proportions, my eyeballs go for the variable, and I set that up as a multiply with the 30. So 30x equals, then I am going to also cross multiply 3 and 276. 828. Oh. Divide both sides by 30. Okay, so I get 27.6 as a calculator answer, but we're talking about people here, so I have to round that up to 28. So they should probably have about 28 burger meals prepared for the 10th grade lunch. Okay, now in real life, realistically, I'd probably make 30 even, just in case, you know, I mean, these are only approximations. All right. All right, lastly, we could be answering some questions from a graph. So here's our graph that's stacked. It says, what % of students overall liked salad bar. Well, let's pretend we don't know that students overall is 30. Remember that like if this graph was something else, we didn't already know that, we weren't already working with this same data, this would be 7 plus 8 plus 6 plus 9, and that would add up to 30 for students overall. Now, it's saying liked salad bar. Okay, students overall liking salad bar, there's 9 students preferring salad bar. We don't get into grade level here. All right, so 9 out of 30, if you divide that on your calculator and convert to a percent, that's 30%. Of the students preferring chicken nuggets, well, I meant nuggets, not nuggets, or nuggest. Oops, typo. Okay. Of the students preferring chicken nuggets, so we're only looking at the chicken nugget column. Okay, what percent are 9th graders? Okay, so let's see, chicken nugget column is 8 kids, and 9th graders, red is my key, and there's 1 of them. So 1 out of 8, which is 12.5%. How many total 10th graders were surveyed? Here again, we're going to pretend we don't already know the answer to that question from already seeing it on previous pages of this data. Okay, 10th graders is the blue. So let's see, from 4 to 7, that's 3. From 1 to 8, that's 7. Whoa, I didn't mean for that 7 to do that. Oh, my pen is acting up again. That's why. Okay, pizza is from 3 to 6, so that's 3. And salad bar is from 5 to 9, so that's 4. Okay, so we're just looking at the blue sections, and that is 17 total 10th graders. Okay, so that's a stacked graph that we're getting information from. Okay, we also could be looking at side-by-side graph. How many 9th graders were surveyed? Well, I just look over here, that's 4, 1, 3, and 5. So that adds up to 13. Okay, and the next question says, what percent of people in 10th grade? Okay, so we're only looking at 10th grade. What percent chose pizza? Well, chose pizza. Pizza is the stripes, and that's 3 out of, let's see, the bottom number, we're only looking at 10th grade, so we're just going to add up 3 plus 7 plus 3 plus 4 is 17. So 3 out of 17. 17.6%. Okay. All right. That is your review for your test, and good luck.